We're now starting page 2 of the Chapter 6 notes, and we're going to look at ionic compounds first. Ionic compounds form when a metal ion, or specifically a metal cation, combines with a non-metal anion. Now, the cations are metal ions, metal atoms that have lost electrons. So, since they have lost electrons, they actually acquire a positive charge. For example, let's consider sodium. If you remember from Chapter 5, if you look at the periodic table, the atomic number of sodium is 11. So that means that sodium has 11 protons, which I'm just abbreviating P+. And since it's a neutral atom, it has to have 11 electrons. Therefore, and I use these little 3 dots when I'm saying therefore, it's a mathematical symbol. Therefore, neutral sodium has no charge. Well, let's look at a little picture of what's going to happen to sodium as it forms a cation. We have the nucleus that has 11 protons in it. So we're going to make 11P+, that's for protons. And there's our nucleus, kind of a big fat nucleus, but that's our nucleus. Now, around the nucleus we have an electron cloud. And this electron cloud has 11 electrons in it. And what's going to happen is one of those electrons is going to take a hike. So the electron leaves. Now, we're going to make the cation when that happens. We still have 11 protons in the nucleus. We don't mess with the nucleus. But now, we only have 10 electrons. And on top of that, our electron cloud has kind of gotten a little bit smaller because we've lost one of the electrons. So now we've got 10 electrons. Let me come back here and put a negative sign by this one. So if we were to add up what we have here, we have a positive 1 charge for sodium because we've got 11 protons and only 10 electrons. Now, anions are nonmetal ions that have gained electrons, and when they pick up electrons, they acquire a negative charge. So let's draw a little picture of what's going on with here. And first we'll start with fluorine. If you look at your periodic table, fluorine has an atomic number of 19, which means it has 9 protons, and it has 9 electrons when it's neutral, so it has no charge. Now let's take a look at what happens to fluorine as it becomes an anion. We have a nucleus that has 9 protons in it. We've got an electron cloud of 9 electrons. And now we're going to have an electron come in and join the electron cloud. So it's going to come on in. And when that happens, we form the fluoride anion. We still have 9 protons in the nucleus. And our electron cloud has swelled now because now we've got 10 electrons in that outside electron cloud. So 10 electrons plus 9 protons ends up with a negative 1 charge. Now what I show here is an ionic compound. And what you have are alternating positive and negative charges. So let's say these are your negative anions and those are your positive cations. So they're just alternating, and they're held together by electrostatic charges. So we have alternating positive and negative charges. So let's write this down here. The positive cations and the negative anions attract each other due to electrostatic forces. In other words, opposites attract. And they form nice big crystals that go on and on. So ionic compounds form crystals where you have these alternating positive and negative charges. Let's go down on the page and we're going to talk about formula units. And a formula unit is the lowest whole number ratio of ions in an ionic compound. So an example would be sodium fluoride, NiF, just like what we had to form up above here. Or another example would be calcium fluoride, CaF2. These would both be formula units. When we're talking about a formula unit, if we're looking at this diagram up here, that right there is the formula unit, which we'll abbreviate as a formula unit, okay? So that would be one cation and one anion together is the formula unit. Now let's look at some properties of ionic compounds. Their melting points are very high because electrostatic forces are very strong, so it takes a lot of energy to separate an anion from a cation. At room temperature, these things are solids. Just like you think of salt crystals, the salt that you put on your food, that's NaCl. That's a solid. And when we throw ionic compounds in water, they do something called dissociate. And dissociate means basically they come apart. Let's say that we throw table salt, NaCl, into water. What happens is the sodium and chloride ions separate, and we have Na+, and we put an AQ after it to mean that it's separated in water. And we have Cl-, and we put an AQ after that one to indicate that it's separated in water. Well, here's a question for you. We were just talking about things gaining or losing electrons. One electron. So we formed a -1 anion and we formed a +1 cation. But we can form anions and cations with different charges. And so that's what we're going to figure out next, is how do we know how many electrons are gained or lost by any particular atom when it forms an ion.